So if we cut it 2 meters, we would have 8 left. Cut it 3, we'd have 7. Cut it x, it's 10 minus x. We take the first part, highlighted in yellow, we bend it into a square, and because we use the entire x to go all the way around that square, that means each side of the square is 1/4 x, 1/4 x, 1/4 x, because we have 4 equal sides, don't we? Like that. Now the other part, we take it and we form it into a triangle, and it's an equilateral triangle. That means I took the 10 minus x and cut it into 3 equal pieces, right? So that gives me 10 minus x, 1/3 of that, 10 minus x, 1/3 of that, 10 minus x, 1/3 of that. So those are just the lengths of the sides. Agree? Now we want to talk about the area, right? Because they want to know, where do I cut it so I get the most area, and where do I cut it so I get the least area when I add the two together? So I'm trying to look for total area of this added to this area. So the total area of both together is the area of the square plus the area of the triangle together. What is the area of a square? It's just the two sides multiplied together, right? So that's 1/4 x times 1/4 x again, right? So just 1/4 x squared. Any questions on that? We're okay? The triangle is the tricky one. How do you find the area of an equilateral triangle? Most people say, okay, if I could have the height, then I know the area of a triangle, but you're not given the height here. So the formula that I recommend you use is the one that I did refer to in class earlier this semester. It says that if you know two sides of a triangle and the angle between them, then the area of that is 1/2 AB sine theta. For us, do we know two sides of this triangle, the equilateral one? Do we know two sides? Sure. I've got this one. I've got this one. Do we know the angle between them? Because it's equilateral, right? All the angles are the same. This is 60 degrees in here. 60, 60, 60. Therefore, this formula becomes 1/2 AB sine of 60 degrees. So area is 1/2 AB sine of 60 is √3/2. So you get √3/4 AB is the area. Did you do it with the height? That what? So you found the height? So the √3/2, same thing, yeah. Okay, so any questions up to this? Now, A and B are the same, aren't they? In that formula, the blue formula there? It's 10 minus x over 3. So this will become plus, here's my area of my triangle. It's √3/4 times the 10 minus x over 3 times itself, so squared. So if I clean this up a little bit, area is all in terms of x, is 1/16 x squared plus √3/4 times 100 minus 20x plus x squared, all of this over 9. What did I do there? What did I do there? I just FOILed out, like the first one, 1/4 x times 1/4 x is 1/16 x squared, right? Everyone's okay with that becoming that? And then what I did is I took this right here and I squared it. Well, 10 minus x squared is 10 minus x times 10 minus x, which if you multiply it all out and collect like terms, you get 100 minus 20x plus x squared. And then you square the 3, you get 9. And then I can distribute the root 3 over 4 through the parentheses on the right to get 1/16 x squared plus, oh wow, okay, 100 root 3 over 36 minus 20 root 3 over 36x plus root 3 over 36x squared. So there I took the root 3 over 4, I distributed it to each of those, and then I divided each of those by 9. I'm doing all that because I'm trying to get it to something where it's going to be easy to take the derivative. I could have taken derivative before, but I'm cleaning it up a little bit. Is there a restriction on x? This is my area function. Is there a restriction on x? 0 to 10, right? The smallest I go is to not cut it at all and use the entire thing to make a triangle, right? Or I could cut it all the way at the end, which really means don't use any triangle and make it all a square. Does everyone understand that? If we let it be 0, we get all triangle. This means all square. So I have a continuous function closed interval. Take derivative. Let's see, 1/8 x, derivative of that's 0, minus 20 root 3 over 36 plus 2 root 3 over 36x. Now you can clean up that 20 root 3 over 36 and all that. Those are just decimals. Set this thing equal to 0. You should get, what'd you get over there? 4 point what? 34? And if I were doing this problem, I wouldn't even care about the closed interval. All I would do is set up a number line, 4.34, and I would just show that it went down then up, which would give me a minimum. And then to find the maximum, I would just plug the 2 endpoints into the original function. Or just use a closed interval method, whatever you're happier with. Okay, I don't want to take any more of the time. That problem's right out of the book. So, interesting problem. Let's get back to where we were. I'm going to give everyone 100 on that. How about, you like that? Is that okay? No complaints on that? Where were we? Where had I stopped? Okay, I remember what I was going to do next. So here's another example. Find area under y equals sine x on the interval 0, pi. So graphically speaking, here's our sine function, right? I'm trying to ask you to give me the area under one of these arcs right here of sine. Haven't you ever looked at the sine function and wondered what the area is under that? Yeah, no. That's why I asked. I don't think you ever have, but now, next time you look at sine, cosine, that's probably the first thing you're going to think. Wonder what the area is under that. Well, what is this as far as this integral thing and all that stuff I've been showing you? Integral sign, right? What do I put on the bottom? 0. What do I put on top? Pi. That means I'm going from 0 to pi. What function am I going to use for the integrand? Sine x and then dx, right? dx just keeps track of my variable, right? At this point in time, as you move into Cal 2, you'll see that plays a much bigger role. Just for now, it's keeping track of my variable. Now, what does that mean? That should tell you right there, find the antiderivative. So what's the antiderivative of sine? Negative cosine. Good. Negative cosine. Now, I put that little line at the end. I put 0 and pi here, don't I? That keeps track of everything. I'm going to take negative cosine x. I'm going to plug in pi. Then I'm going to plug in 0. Then you put equals. I always love to put 2 sets of parentheses. First one is what I get when I plug in pi, so negative cosine pi. The other one is what I get when I plug in 0, negative cosine 0. Notice my negatives there, right? What is cosine pi? Negative 1. So I have negative 1. What is cosine 0? 1, so minus 1. So what is negative 1? 1. What's minus 1? Plus. So the answer is 2. The area under that is 2. That's right. Doesn't seem like it would be a nice number like that, right? It is. Much like E. Now, I'm curious, what if I were to change this problem? Instead of making it go from 0 to pi, what if I were to come up here 0 to pi, and what if I were to change it to 2 pi? Do you think the answer would be 4? Well, all that would change would be, watch, I'm working with this integral, it would be 2 pi here, right? It would be 2 pi here. Do y'all see where I'm changing this? It would be 2 pi here. What's cosine of 2 pi? It would be 1. So I'd have negative 1, but then plus 1, which would be 0. What does that mean? It's counting anything below the x-axis as negative. And it comes back to the idea of the rectangle. Do you remember when we said that when we take a rectangle in here, we said how high is it? And we said it's the function's value, right? F of x. But what if f of x is negative? Then it counts that little rectangle as having a negative area. Even though we know it's not negative area, it's a negative number times a positive number, which gives you a negative. So it counteracts the top side, and you get 0. So you have to be careful with things like that. So in a Cal 2 class, as you move on, you are not going to have this in this class. You would have to find out where the x-intercepts are. If they ask you, what's the total area under this curve? Then you would have to find the x-intercepts, break it up, and do them piece by piece. And so you would make two integrals, one going from 0 to pi, the other integral going from pi to 2 pi. When this answer over here, when this answer comes out to be negative 1, you would actually make it a positive I'm sorry, negative 2. You make it a positive. Okay, that's beyond the scope of this class. All right, let's talk about the final. Okay? Talk about the final. So let me pull out